Subscribe now and click on the bell icon to never miss learning from Vedantu.
In today's class, we intend to do something called as electric potential. Right? So in today's class, we will be focusing on the topic of electric potential. So kids, I hope we all are ready. Get set, go. Okay. Chalo, that's spectacular. Now, so talking about electric potential, so the question is, what exactly is potential, my dear kids? What is potential? So we have already done the topic of electric field, wherein we have discussed that every charge exerts some field around itself. It has some area of influence around itself. That area of influence has something called as electric field that we've already done. That area of influence can also be studied in terms of electric potential. So the point is that every charge or system of charges have some electric potential around it. Have some electric potential around them. Right? Every charge or system of charges have some electric potential around them. And when some other charge is brought, in this region, then some work has to be performed. Right? So, to define electric potential, let us consider that we have got some system of charges. Let's say this is some system of charges. It may be a point charge, it may be a combination of charge, it may be a solid sphere, it may be a hollow sphere, it may be any system of charge. Now, in the system of charge, let me consider a point where we are supposed to define potential. Now, the idea is, let's say if I bring charge Q0 from infinity and place it at point A, then the change in potential energy of the system will basically be equal to work done by external agent in bringing the charge very slowly. This is simple work energy theorem, that if charge is brought very slowly, then essentially there is no change in kinetic energy. Therefore, change in potential energy will be equal to work done by external agent. Am I right or wrong? So we define something called as if we take potential energy at infinite separation to be zero, so we can say that potential energy when the charge is brought at A, is basically what? Work done by an external agent per unit charge. Yes, Nayan, it slowly implies velocity is very zero. Right, kids? Slowly implies there is no change in kinetic energy. Delta K is zero. Sorry. So, potential energy at A will be equal to work done by external agent. Now, we define something called as potential at A. Potential at A is defined as what? Potential at A will be basically work done by external agent per unit charge in bringing a charge from infinity to point A. It is work done by an external agent in bringing a charge from infinity per unit charge from infinity to point A. So that is over here, yes, very slowly. So what do we define? We define electric potential at point A equal to what? Work done per unit charge in bringing charge in from infinity to point A very slowly. This essentially becomes what? Potential energy of the system per unit charge. This essentially becomes what? Potential energy of the system per unit charge. So from here, kids, what do we get? So from here, kids, we get that potential is basically a scalar quantity. We get potential is a scalar quantity. And second thing, what do we get? We get SI unit of potential as, my dear kids, joule per coulomb, which is also referred to as volts. Right? So kids, what am I saying? I am saying electric potential is defined at every point, and it is basically work done by an external charge, by an external agent in bringing a charge Q naught from infinity to point A very slowly per unit charge. So what is potential, my dear kids? It is work done by external charge by Q naught in bringing the charge from infinity to A very slowly. This is potential at A. Right, kids? Do you get the definition of electric potential? Do you get the definition of electric potential? Now, when we say the definition of electric potential is this, now as a physics student, what are we concerned with? As a physics student, as we said earlier, we are concerned with two things. One, potential due to any charge or system at any point. Second, how can we find potential and how is it related with field? And last, if we know potential, then how can we find potential energy of a system using the ideas of potential and potential difference? Using ideas of potential and potential difference. Now, kids, Nayan is asking me a very wonderful question. Nayan is asking, is this definition valid only for infinity? Well, the answer is, to be honest, if you want to ask my honest opinion, the answer is no. It's not that it is valid only for infinity. Right? It is actually, why we say infinity, because we generally take potential at infinite separation to be zero. This is a general assumption that we have. Yes, Adityan. Right? This is the general assumption that we have. Potential at infinite separation is for any charge or for any, we define generally potential at infinity point to be zero. So basis this, this definition holds true. Right? Basis this definition holds true. Do you get my point? Basis this definition holds true. Potential difference is perfectly fine, but potential exactly is this particular thing. Right? So what I'm saying, assuming potential at infinity to be zero, just a second, I will help you better, just give me some time. So potential at any point is defined as work done by external agent in bringing charge from infinity to point A. So actually this is not potential, this is potential difference. This is potential of A minus potential of infinity. In actual, if you want to know some actual stuff, is this. Now if we assume V infinity to be zero, then we get potential at A to be this. Am I right, kids? Do you get my point? Do you get my point then? Okay. So coming back, my dear kids. So what I was saying, Deveshwar, it's not necessary to expand it. It's just to make you understand. Yes, Rishad, its potential difference is unit is voltage. Now, so kids, potential, there are three aspects to potential as discussed right now. So we shall be first focusing on this aspect. This is our first point. Then we shall be discussing about this. This will be our second idea. And then we shall be discussing on this front. So this will be our third idea. All right, kids. Is that clear? Okay, kids. Can we concentrate on this topic and not focus on other topics? If you want me to give you a brief idea, we are discussing potential and potential energy right now. In next class, we shall discuss the ideas of dipole, right? We shall be finishing this topic at the end of dipole. And post that, we shall be starting with electric field lines and hence Gauss law. Okay? Okay, bachcho, I hope I am clear. So if everything goes right, probably by the end of next class we shall be finishing electrostatics, except field lines. Field lines will be covering with start of Gauss law. Otherwise, I've already given you field lines notes. If you have revised, probably many of you would have already done field lines from the notes that I've shared. The class notes. All right, kids. So I hope our concentration is set for today. Agenda is clear, bacho. Cool. Thank you, bacho. Kids, I hope I'm audible. You are not finding me slow or boring. I'm audible, right? Okay, cool. Now, coming back, my dear kids, speed बढ़ाऊं कि आवाज बढ़ाऊं, volume बढ़ाऊं? अच्छा, don't worry. Speed आप मेरे पे छोड़ दो. हाँ, potential due to different systems. So, let's say एक चार्ज Q है और A पॉइंट पे उसका क्या पोटेंशियल होएगा? एक चार्ज Q है और A पॉइंट पे उसका क्या पोटेंशियल होएगा, my dear kids? Potential due to charge Q at A point will be equal to what? KQ by R. So, first thing is, what is potential due to a point charge at any point A? Potential due to a point charge at any point A will be what? KQ by R. Right? किसी भी एक पॉइंट पे पोटेंशियल की वैल्यू होती है क्या? KQ by R. All right? Never mind, Dhruti. Right? So, अगर चार्ज पॉजिटिव है, if charge is positive, then potential is positive. And अगर चार्ज नेगेटिव है, then potential is negative. अगर चार्ज पॉजिटिव, then potential is positive. अगर चार्ज नेगेटिव, then potential is negative. Right? Now, what if there are a combination of charges? Potential is a scalar quantity, so there is no direction of potential. Potential due to combination of charges. Now, let's say there are three charges, Q1, Q2, and Q3. and we are supposed to find potential at A due to individual charge. So this is R1, this is R2, and this is R3. Now, the beauty of this potential is, it is pretty straightforward. It is basically what? Scalar sum of individual potentials. It is what? Scalar sum of individual potentials. Do you get my point? It is pretty simple. Electric potential is what? It is scalar sum of individual potentials. Unlike field, in field we had to take care about the directions as well. We had to see how to add vectorially. Yes, this is principle of superposition. This is principle of superposition. In fields we had to take care of directions, but over here there is nothing called as direction for potentials. So life is peace here. Life is jingalala in this case. Right, kids? Now, moving ahead, my dear kids. So potential due to combination of charges is this. Now let's talk of potential due to some continuous charges out here. Potential due to ring at center and at axis. Now, if I talk of potential due to a ring at the center or at the axis, so let's consider these two cases. Now, let's say we have got charge Q, which is distributed on the ring. And in this case also, charge Q is distributed on the ring. Let's say radiuses are. Now, what will be potential at point O? Now, potential at point O, my dear kids, there is nothing to integrate out here. Can you tell me all the charges on the ring are at how much distance from A? All the charges at the ring are at how much distance from A? So for every single point charge, I can write potential to be K Q by R, and if I add all the potentials, the total potential will be what? K Q by capital R. There is nothing to integrate here. Am I right, kids? Now, in this case, if I talk of potential at A, now in this case, can you tell me all the charges on ring are at how much distance from A? All the charges from ring are at how much distance from A? All the charges on the circumference of the ring are at how much distance from A? No, they are not at R. No, bache, they are not at R. R is the radius from this. Can you tell me? Oh, they are dependent on this distance? Right, kids? Right? And what will this distance be? If you remember Mr. Pythagoras' uncle and unki atma ko ठेस ना पहुंचे, तो I hope you all know what is this distance? So वहां पे चौका, what is the potential at A? Therefore, potential at A will be what? K into total charge upon this distance R square plus X square. Is that clear, bachcho? So, potential due to ring of charge at center is KQ by R. Why no integration? Because all the charges are equidistant from A. So, there is no point. And moreover, my dear kids, in this case, it's a scalar sum. So, directions का भी ध्यान नहीं देना. तो इसलिए यहाँ पे इंटीग्रेशन की कोई आवश्यकता नहीं. In first case, it's at the center of the ring. It is the center of the ring. In second case, it's on the axis of the ring. kids? कोई बात नहीं प्रथमेश. Right kids, should I proceed ahead? Yes, whose doubt is there? Just a second, somebody is asking doubt. किसने hand raise किया है? हाँ मृणांक बताइए क्या पॉइंट है आपका? हाँ जी गोगो मास्टर.
हेलो सर.
यस गोगो जी.
यस सर. सेकंड केस में रेडियस कॉन्स्टेंटली चेंज नहीं होगा क्या सर?
रेडियस कॉन्स्टेंटली कैसे चेंज होएगा मेरे दोस्त?
लाइक आपने ओवल टाइप का बनाया है ना सर, तो लाइक
ओवल नहीं है. ये रिंग है जिसके एक्सिस, मतलब एक रिंग है जो एक्स वाई प्लेन में और ये जेड प्लेन में है.
ओ अच्छा, ओके सर. आई मिस्टूक इट फॉर ओवल थिंग. सॉरी सर.
समझ गए? ये मेरी डायग्राम बहुत सुंदर है. ये तो आपने मेरे डायग्राम ड्राइंग को बेइज्जती कर दिया है.
नो सर.
Okay. Anyways, I was just kidding. Chalo, thank you, Ajay.
Yes.
So coming back, my dear kids. So potential due to ring at the center and at axis clear है. Now यहीं पे बच्चों अगर मैं बात करता हूँ arc की. Let's say we have got an arc having total charge r, subtending angle theta at the center. Now, can you tell me what is potential at A? Can you tell me what is potential at A? In this case as well, potential at A will be equal to what? KQ by R, not R square. Potential की बात करें पहले तो R square की बात नहीं करेंगे. दूसरा, all the charges in this case as well are at same distance R from the center, right? In this case also, all the charges are at same distance from the center. So यहाँ पर भी same से expression आएगा. तो जरा बोझ पानेगा नहीं अपन को. Am I right?